Last week we learned about the different types of reactions. So we learned about exothermic and endothermic reactions. You'll remember that we were talking about how exothermic reactions are reactions that produce energy, and endothermic reactions are reactions that absorb energy. And then I asked you to answer these questions. So we have this experiment, all right, where different fuels gave out energy when they are burned. So we have here the fuel being burned, and this is water that warms up when the fuel is burnt. Okay, and we measure the temperature of the water at the start of the experiment and at the end. Now, you can imagine this is very much like heating up a pan of water on the cooker. All right, so when you start, this is room temperature. So the water is just water you take out of the tap, and you heat it up for a bit, and then you measure the temperature again, and the temperature is increased. So the first question is, are the reactions exothermic or endothermic? Well, the reaction, remember, is happening here. All right, so the fuel being burnt, that's the reaction. That reaction gives out energy, okay, and it's the giving out of energy that warms the water up. So what do we call a reaction that gives out energy? We call it an exothermic reaction. Okay, how do you know the answer to question number one is exothermic? Because the temperature has increased. Remember, last week we had these three different things for exothermic reactions, and one of them, the third one here, the temperature of the surroundings increases. So here, the water is the surroundings, all right? So the water is the surroundings, so we can say that the temperature of water increases. Number three, what was the temperature change when 1 gram of ethanol was burned? All right, so this is ethanol here, and this is 1 gram for each of these, so we want to know what's the temperature change for 1 gram. It is just going to be 36 minus 19, which is 17 degrees C. Which fuel released the most energy when it was burnt? Well, we need to do the same calculation for all of them. So what I can do is here, I do 36 minus 19 equals 17. 47 minus 20 equals 27. And 41 minus 18 equals 23. All right, so we can see that this one here, the temperature has gone up by the most. So that is going to be the most energy released. So the answer to that one is paraffin. Why is it important to burn 1 gram of fuel in each experiment? That's so that we can compare these numbers, all right, to make it a fair test so that the numbers are comparable. Because obviously, if this one here was for 1 gram, and this one here was for 1 gram, and this one here was for 100 grams, then I wouldn't be able to compare the numbers. All right, so it is to make it a fair test. All right, so in the same way, I'd need to use the same amount of water as well. The temperatures of reactions of zinc, magnesium, and nickel with hydrochloric acid were measured. The results are shown in the table. Calculate the temperature change for the calcium reaction. Okay, so the temperature change here is 57 minus 19, which is 38. Magnesium is more reactive than zinc, but less reactive than calcium. Predict the temperature change for a reaction between magnesium and hydrochloric acid. Okay, so magnesium is more reactive than zinc. So it's more reactive than zinc, but less reactive than calcium. So it's going to be somewhere in between here. So as long as you give me a temperature change that's anywhere between 11 and 38, I will be happy with that. So anywhere between 11 to 38, any number that's between those two. What name is given to reactions which give out heat? Those are exothermic reactions. What temperature change will be observed for an endothermic reaction? Well, remember from last week, the temperature of the surroundings decreases in an endothermic reaction. So you would see a temperature decrease. Suggest another reaction which would give out heat. Okay, so this is quite a difficult question. This is asking you for another kind of reaction. So here, this is a metal plus an acid, and it's exothermic. What else is exothermic? Well, if you read the part at the start, here you've got examples of exothermic reactions, such as combustion. So combustion would be an obvious answer. Because, if you think about it, combustion is burning. When you burn things, the temperature goes up. That's an exothermic reaction. All right, which gives out heat. Moving on. So down here, a student investigated the reaction of magnesium with hydrochloric acid. A piece of magnesium was dropped into the hydrochloric acid. Use your notes from when we studied acid to write a word equation. So we did this just before the lockdown. Remember, we did a lot of practice of writing these equations. So it's magnesium plus hydrochloric acid will give you magnesium chloride plus hydrogen. And in your answer to question number 9, indicate which substances are reactants and products. So the reactants are these ones here on the left. These are the reactants. And the products are these ones on the right. These are the products here. In your answer to question number 9, indicate which substances are elements and which are compounds. This one's a little bit trickier. So the elements, all right, so magnesium, that's an element because there's only one type of atom. Hydrochloric acid, that's a compound because there's more than one type of atom. There's hydrogen and there's chlorine. Magnesium chloride, that's a compound because there's more than one type of atom, magnesium and chlorine. And hydrogen, that's an element because there's only one type of atom, hydrogen. Why does the mass of the substances decrease as the reaction goes on? Okay, so when you're doing this reaction, okay, it looks like this actually. So down here, we can imagine this is what the reaction looks like. The piece of metal is in the acid and there's all these gas bubbles coming off, and the gas bubbles are hydrogen gas. So the reason the mass decreases is because hydrogen is given off as a gas. All right, so H2 gas produced. So remember, in a chemical reaction, the mass must stay the same. But if one of the products is a gas that's lost, the mass will appear to be decreasing because the gas is escaping. The reaction is exothermic. Which two measurements would the student make to show that the reaction is exothermic? Okay, so you would need to measure the temperature before you add the magnesium. Okay, so number 1 would be before adding magnesium. So you just measure the temperature of the acid. Okay, and then number 2 would be after adding magnesium. So you would measure the temperature of the acid before you add the metal, wait a little bit, measure the temperature again. Okay, and once we go back to school, we can do that. How would the measurements from question 13 show that the reaction is exothermic? Okay, well, the temperature after adding magnesium would be more than before adding magnesium. Okay, so temperature after adding magnesium more than temperature before? I think. The student investigated how changing the concentration of hydrochloric acid affects this reaction. Each test tube contained a different concentration of hydrochloric acid. The diagrams show the results of the experiment. Suggest one control variable. So one thing you must keep the same, okay? I'm going to give you a few. So in this experiment, things you need to keep the same are volume of acid. Number 2, mass of magnesium. Number 3, the temperature. You need to keep all these things the same in order for it to be fair. All right. Which test tube A, B, C, or D contain the greatest concentration of hydrochloric acid? Okay, test tube B. All right, because more bubbles are produced. Which test tube would show the smallest temperature change? All right, you would expect that to be A. Yeah, because there's not much reaction in A, so you wouldn't expect a very big temperature change.